Yes.
Okay. Yeah. So today's topic is forecasting. What do you mean by forecasting? Forecasting is nothing but predicting the future. Forecasting simply means you are predicting the future. You are estimating the future. You presume something about the future. Okay. Now, so in this chapter, we are going to study about correlation and statistical forecasting techniques. We are going to study about linear regression. We are going to see about the coefficient of determination. We're going to study all this in details. Okay, let us start with correlation first today. Then we are also going to see the topics which comes under this. Under correlation, we are going to study about the concept of correlation, scatter graphs. Okay, that is a graph which shows you about the correlation. Okay, between two variables. So we will see that also, and that as well. And we are going to see about the regression lines and also advantages and disadvantages of this analysis. Then we are going to study about the coefficient correlation, which is correlation coefficient, which is denoted by R, and also the coefficient of determination. What do they say? And then we are going to discuss about the time series analysis, very important for forecasting index numbers and sales forecasting the product's life cycle. Okay, let's go ahead. And different models as well in this time series. So what is meant by correlation? So correlation is nothing but it is that number, okay, which tells about the relationship between two variables. Not relationship, I would say, which tells about the strength of the relationship between two variables. Okay, which tells about the strength of the relationship between two variables. Okay, now see, when will you say that two variables are correlated or they have certain relationship? When change in one variable would definitely cause some changes in another variable. For example, if like TCS is a part of Bombay Stock Exchange, BSE, then if the BSE market would crash, TCS stock would also be affected. Do you think there is a relationship between these two? Yes?
Yes, sir.
Of course. And we can take some other variables as well like sales and advertisement. If you increase your advertisement, your sales would increase. Okay. Demand and price. If the price increases, demand decreases. If the price decreases, demand increases. So change in this is causing change in this. Change in this is causing change in this. So they are correlated. Okay, they are, that means there is some kind of relationship between them, some correlation between them. Okay, but how strong that relationship is, that is what only the correlation is going to tell you. So correlation always is between scale of -1 and +1. 0 comes between these two values. -1 means perfect, negative correlation. Just a second. Okay. Why these people are so strange that first they give regression, then they give correlation. We'll do first correlation, okay? Today we'll focus on correlation first, then we'll go for regression tomorrow. This is perfect negative correlation. This is perfect positive correlation. This is zero or no correlation. Okay. Yeah. Just a second. there is zero or no correlation. That is what this means. Now, what is perfect positive correlation? What is perfect negative correlation? What is zero correlation? See, I take two stocks. These are two banking stocks, Kotak Mahindra Bank, HDFC Bank. So let's say, like, if I tell you the correlation between these two is 0.70. Are you understanding what I'm saying? Hello?
Yes, sir.
If the correlation coefficient, which is denoted by R, between these two variables, which I have calculated right now, that means I'll show you the calculation as well, is 0.70. What is the interpretation of this? The interpretation of this is, if Kotak Mahindra Bank stocks would go up, there is 70% chance that HDFC Bank stocks would also go up. Or if Kotak Mahindra Bank would stock would go down, there is 70% chance that HDFC Bank stock would also go down. Correct? This
Yes,
shows
sir.
the strength of the relationship, how strong the relationship is. If something happens to this, 70% chances that this will also be impacted. So we are getting the we are getting to know to what extent this is impacted or affected. So to what extent this is impacted or affected, 70% impact we can see. Right? If the correlation is 1, that means if Kotak Mahindra Bank stock would go up, 100% HDFC Bank stock would also go up. Correct? This is what. And if it is -1, if Kotak Mahindra Bank stock goes up, 100% chance that HDFC Bank stock would go down. Understood? Hello?
Yes, sir.
Negative in sense, one goes up, another goes down. Positive is not only going up. If Kotak Mahindra stock would go down, yeah, I already explained you. So you want to make a note of all this, or shall I move forward?
So I'll make a note of it.
Okay.
Done, sir.
So we will discuss about correlation now. We have just seen the intuition. Let us understand how to calculate the correlation, how to find out the correlation coefficient, correct? See, correlation coefficient denotes is denoted with the letter R, and it also they say that correlation coefficient measures the degree of linear correlation between two variables. That means how one variable can have, how change in one variable can have an impact on another variable, and there is a linear relationship in the sense, like, there will be, if this is affected by 10%, the another will also be affected by 10%. Understood? That is it. That is a linear relationship, correct? Why? Because if you see, for something to be in linear relationship, it should follow this. It should have have this concept of this line. Okay, that means it should satisfy this equation of line y is equal to a plus bx. Are you understanding, Amsika? If something should have a linear relationship, it should satisfy this line equation. That means if you make a graph, a line should be formed. Then only we can say it has a linear relationship, correct? So that we are going to see how strong the linear relationship is. We are going to see the strength of the linear relationship between two variables. How strong the linear relationship or the strength of the linear relationship is. In this, A is y-intercept. Let's say this is the point at which this line is touching the y-axis. This is 2%. This is constant. B is the slope coefficient, which is always constant, which shows change in y-axis by change in x-axis. Okay. So how the changes in y-axis is happening with respect to changes in x-axis. That means if I take two variables, let's say this is Kotek, this is let's say sales and advertising. This is like say the sales figures, and like if you this is, let's say, advertising expenses in x axis, sales figures. Okay, so you spend $100, and your sales has gone to 20%, like 20 units. You spent $200, your sales has gone to 40 units. Okay, so that shows a linear relationship. Now it's increasing or not? First point, second point, then third point you will put, correct? And then if it goes to 400, then your sales will increase by 80 units. So exact changes are happening or not? Please tell me.
Yes, sir.
So what we can do is we can find out the slope coefficient. Now slope is like this. So slope coefficient would be change in y-axis. That means I have gone from 0 to 100. So 100 minus 0, and my sales increased from 0 to 20. So 20 minus 0, I'll get 5. Secondly, if it has gone from 100 to 200, so 200 minus 100 divided by 40 minus 20. Again 100 by 20, I'll get 5. So this won't change. So 5. Now x I can take. So this is the equation I've got. So I've got, so 2% is 0.02, let's take, plus 5. Let's take some imaginary figures into x, y. So I will take any value of x and I can get value of y. Correct or wrong?
Correct, sir.
That shows the linear relationship or a straight line relationship. Okay. So here you see this is very scattered one. There is no correlation. Here there is, as well as like any correlation. Are you seeing? No correlation. Okay. Zero. Because we don't see any changes in y-axis if there's a change in x-axis. Correct or wrong? Do you think this is like constant, na? For any value of this, the value here is same. Correct or wrong?
Correct, sir.
But here we see perfect positive correlation, because as we are increasing the advertisement expenditure, the sales is increasing. Or as we increase the price of the goods, prices here, the supply increases. So there's a perfect positive correlation. It is left to right upward sloping, and this can be taken in terms of price and demand, which has perfect negative correlation, because when price is increasing, the demand would decrease. Correct? Yes. This is.
Yes, sir.
These are the four figures, and this is the formula for finding out the correlation coefficient, which was given by the Carl Pearson, and the formula is n into sigma xy minus sigma x into sigma y by n sigma x square minus sigma x whole square, and into n sigma y square minus sigma y the whole square. Please write down the formula. You have to do one question right now.
So only when y is equal to a plus b is satisfied, there is a linear correlation between two variables, sir.
Sorry. Yeah,
So
this y is equal to a plus bx line like this shows the linear relationship. In this, y is nothing but the dependent variable, x is independent variable. So if I take example of sales, so sales is nothing but sales figures are dependent variable, am I right? And advertisement is independent variable, correct? That means if you change, if you increase the advertisement, your sales may increase. Or if I take demand and price. See, demand is a dependent variable, correct or wrong?
yes, sir.
Demand depends upon what? Price. Price is an independent variable. That means if I increase the price, the demand may decrease. If I decrease the price, the demand may increase. That's what. And this is y-intercept. This is the point at which the line touches the y-axis. This is slope coefficient. This is also constant.
So price would be independent, sir.
Of course, independent, na? Does the price depend on demand or price demand depends on price?
Yes, sir. Demand depends on price.
That's what. Yeah.
So price depends on cost.
No, please don't take all this. Like cost is something which is a part of price. Okay. So see, you can see that if the price is 10 rupees and the cost is like 5 rupees. So you know if the price increases, the cost increases, the price may decrease, na? The profit may decrease. So price and like cost and profit can be taken as something, na? Your profit depends upon cost, isn't it so? Hello.
Yes, sir.
Profit is a dependent variable of cost. How? If the cost increases, profit decreases. Cost decreases, profit increases. Does it make sense?
Yes, sir.
Okay. Now make a note of this.
So over, sir.
This question. So what you have to take? You have to take x, you have to take y. These are given, then you have to find out x into y. Okay. Then x square and y square as well. Okay. So this all we are finding out. X, y, x, y, x square, y square. Correct or wrong?
Yes, sir.
And then totals of all. And then you have to put in this formula. Will you do this right now?
Do.
Yeah.
So here n would be the number of months.
Yeah, n is the number of terms. Yeah.
So am I supposed to add 1 plus 2 plus 3 plus all of that, or should I just take 6?
No, no, 6. Number of terms, not of terms. Number. Count
Okay,
it.
sir.
Yeah.
So I'm getting 0.02, sir.
Today we are going to talk about weight development in answer is exactly 1. Just check it out.
Yes. Yes, I'm getting one.
Okay, yeah. So there is one more activity. What is the correlation coefficient for data in the previous activity? Wigwam company. So is this Wigwam company? What's the data? I think they give. From where they bought this Wigwam company actually? Oh no, from where they have bought. Okay, let's check what they are saying. So there is a perfect positive correlation. Am I right?
Yes, sir.
Hello? Yeah. What is this coefficient of determination? They have not given nothing about this. So coefficient of determination tells how well the it measures the variation actually. Okay, that means like if one variable is, suppose x is one variable and y is one another variable, the variations in this whatever are caused, okay, so it measures the proportion of total variation in the value of one variable that can be explained by variations in another variable. That means how the variations in this is causing the variations in this. Understood? So this particular determination coefficient explains you that in a more in the best possible manner, the variations in this variable, how it creates a variation in this variable. Correct? Hello?
Sir, so the correlation tells us about the strength of two
Strength of the
variables.
relationship. Yeah.
And coefficient tells how it affects the other variable.
Coefficient of determination tells how the variation in one in the sense how the variations in one is creating variations in another.
Okay, sir.
Yeah. So you can make a note of this. That means, see, you expected the variable to be 10%, but it is coming to be 11%. So that's a variation, na? Your expectation is how much? Hello.
So 10, sir.
But it is coming how much? 11%. So that variation of 1% can be properly explained by like the variation in one of the variables. It measures the proportion of total variation in one variable. So here the variation is how much? 1% of one variable that can be explained by variations in another variable. That means this variation which is caused here can be because of some other variable. Correct? Which is with which this particular variable is correlated. Am I right?
Yes, sir.
Yeah, see, the GDP, see, the Indian economy is impacted by various factors: GDP, inflation, recession, and political factors. So all these factors, there will be some kind of variations in these factors. Those variations can have an impact on India's economy or not.
Yes, sir,
Tell
they
me.
can.
So that kind of variations can be properly explained by coefficient of determination.
Okay, sir.
Yeah. So I can write here this coefficient of determination is divided by R square is used to analyze how differences, or in our with textbook version, variation in one variable can be explained by a difference in second variable. Correct? So how India's economy can be affected because of the various factors which I explained you right now. Some good example, when a woman gets pregnant, that has a direct relation to when they give birth. Correct? Like suppose like a woman will give birth after 9 months, isn't it so? So the day when she is pregnant, from that day to 9 months, isn't it so?
Yes, sir.
So this factor, this can decide now when the childbirth will happen. Correct or wrong?
Yes, sir. So here, what would be the correlation then?
See, they have relationship. That's why that is the reason why you are finding out the determination coefficient. Now, without correlation, how will you find out the determination coefficient? They will see first. They should have some relationship. Then only variation will be created. Na?
Yes, sir.
Okay. So what does it say? This coefficient of determination is always between 0 and 1. The coefficient of determination does not prove a cause and effect relationship. It merely suggests a possible link. Value must be between 0 and 1. This also you can note down.
Done, sir.
Yeah. So now next, what are we going to do? We are supposed to do the next concept of regression. So next topic we have to do regression. Shall we do that regression tomorrow? Hello?
Yes, sir.
Yeah, because tomorrow I'll wind up regression. So we will be finishing regression, which comes here. From here we have to start. Basics we have covered, just we have to do the questions. After this, next topic would be time series. See, this is not a big chapter. Hopefully, if time permits, we can try to wind up this by, like I told, not 1 or 2 classes. That's it. So by day after tomorrow, I can finish 4th chapter also. Okay. So tomorrow we'll continue with regression, and tomorrow I'll finish time series. I'll finish totally. Okay.
Yes, sir.
Then what happens next is index numbers. Day after tomorrow, index numbers I'll wind up. We can start the next chapter then. Forecasting would be done. Next one is summarizing and analyzing data. We'll do that one. Okay. Okay, then tomorrow 8 p.m. I'll be ready for the class. Okay, Amsika.
Okay, sir.
Today
Yes.
actually my Skype was not working. It was giving problems, and when I again tried to log in, again it was not. I was not able to call. That's why it got late today. Tomorrow I'll be exactly on time. Huh?
Yes, sir.
Okay, okay, Amsika. Thank you.
Thank you, sir.
Thank you.